Hi everyone, welcome back to another Calculus 12 video. We are doing 7.3 derivatives of other trigonometric functions right now. And we're starting off with stuff we already know, d dx of sine x over cos x. So we know that we want to apply the quotient rule to this. So I'm going to call that f, I'm going to call that g. Actually, I feel like using pink. I haven't used pink in a while. So just a recap of what this looks like, the quotient rule would be f prime g minus f g prime. And the whole thing is over g squared. So just a quick reminder, identify or label which one's f, which one's g. We know that that's what the quotient rule looks like. And now we simply plug stuff in. And the rest of it, this is why I keep saying, there's nothing else that's new. That's all that we're really doing today. So for the first part, if we want f prime, we know that the derivative of sine x would be cos x. Okay, then times g, well our g already is cos x, so that's happening. Minus, that does not look like minus f, which is our original, so sine x. Times g prime. So g prime we know is negative sine x, right? The derivative of cos x is negative sine x. So we put that in there. And then all over g squared. So it'd be all over cos squared x. So this is just a matter of like plugging things into formulas. I'm going to assume at this point that you all know the quotient rule, you know the product rule, you know the power rule, like you know all the rules. And if not, make sure that you do. Make yourself a little study sheet, write them all down, memorize them because you will need that. And then the rest of this becomes the same old thing that we always do, which is simplification. So let's work our way through and simplify this. We can see here that we would get cos squared x. And then here we would get plus sine squared x all over cos squared x. Okay. We know that cos squared x plus sine squared x is the same thing as the number 1 from our Pythagorean identities. So 1 over cos squared x, and remember, like we haven't done those yet, but remember there's secant, cosecant, and cotangent. So 1 over cos squared x, the best way to say that is secant squared x, because we know that, well, we memorized that or know that from Pre-Calc 12. Okay, so I'm also going to give you another new one. So we have secant squared x. That's going to be our answer there. And just a reminder that sine x over cos x is equal to tangent x. I think I did that in last day's lesson, and you know that from before, but I'm just throwing in or building in that reminder. And I'm also going to show you another new thing here. I'm going to do it over here in a separate color. If we have d dx, no, we need like a brighter color. Let's do d dx of tan x. That's equal to secant squared x. Secant squared, oh, what is happening? Secant squared x. Put it in a box, put a big star around it. You need to know and memorize this, and it's going to come in handy. Okay, so d dx of tan x, because I feel like that didn't look good, is equal to secant squared x. Okay, so let's take a look at another example. If we have d dx of cosecant x. Okay, so just a reminder that cosecant, because it's been a little while, is the same thing as, so let's rewrite this. That's like saying 1 over sine x. Okay, so we could again do the same old thing. Like I can say, okay, that's f and that's g. And we can do our quotient rule. So again, according to the quotient rule, I would do f prime times g. So f prime in this case would just be 0 times g, which is sine x. Well, I feel like I should do pink if I'm going to do that. So sine x. And that doesn't matter because it's 0 anyways. Minus, it would be g prime. So g prime here would be cos x times f, which is just the number 1 from up there. So it doesn't really matter. The whole thing would be over g squared, which is sine x. So it would be over sine squared x from the bottom here. Okay, so this part we already talked about. It's gone because it's times 0. So we actually have negative cos x at the top over sine squared x. Okay. When we work our way through that, that's like saying, I'm going to move it down here, equals negative cos x over, I can separate them, so sine x times 1 over sine x. The reason I did that is because cos x over sine x is the same thing as, I'm going to carry on this way, so this part here is the same thing as saying negative cotan x. That's not thick enough. Negative cotan x. Okay. Times, well, 1 over sine x, so this part is the same thing as saying cosecant x. So this is built-in review. I don't know if you remember this, but it's been a little while. So after all that work, this is what we end up getting for our solution. Negative cotan x, cosecant x, as we work our way through. See, they're kind of like fun little puzzles. You're just looking for ways to simplify, break them apart, so that you can start to cross things off and find a solution. So how about d dx of secant x? For d dx of secant x, we could have d dx of 1 over cos x. And again, we could do the quotient rule, where we know that this would be f, this would be g, and we know that it's f prime g minus g prime f over g squared. I'm not going to write it out again because I think you know it by now, or hit pause and write it out for yourselves, but I'm just going to flow through and get the answers here. So if we take the derivative of this, so f prime would just be 0, right? And times g, which is just the bottom, cos x, I mean, really, we don't need to write it because it's going to be gone anyways, like that's all wiped out, minus negative sine x because we take the derivative of the bottom, so negative sine x, times 1, which is just what we had at the top, and the whole thing is over g squared, so cos squared x. So notice what we have here. Negative and negative makes a positive, so we would end up getting sine x all over cos squared x. And we can split that up just like last time to say sine x over cos x times 1 over cos x. And when we work our way through that, sine x over cos x is tan x, and 1 over cos x is secant x. So tan x, secant x would be our solution. I hope you found that helpful. There's your work for the day.